Hello friends, this is part 3 of sorry, let me clean this. Part 3 of solved paper Nuclear and Particle Physics DAC 1 of 2023 Dibrugarh University. If you follow me on Insta, this is my Insta ID OJALAKHYAJIT 123. This is paper of 6th semester of CBCS system. Okay, so before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. So now let's start. So in the last video we have solved up to question number 3. Now we're going to solve question number 4a and b. So here you see, describe how the range of alpha particle can be determined, what is the struggling, and write down the relation connecting the range and disintegration constant. Okay, now you see, what do you mean by range? Range is the distance through which an alpha particle travel through a specific material before stopping, right? So that is the range. So there are different methods to determine this, but we're gonna discuss about today Geiger-Nadel method. Okay, so in this method, first take the screenshot of this. So first let me go to the diagram straight away. Okay, here you see, so this is a bulb. Bulb is not the kind of bulb, you know, that when that it consists of filament which glows, not that kind of bulb. So here we have a metal plate M, and this is the bulb. Here you can see, and here you see we have applied a potential difference here, and the inner surface of this bulb is silver coated. Okay, this is silvered. Okay, so here we have applied a potential difference. Okay, this is electrometer to measure the current, measure the saturation current. Okay, now here you see, so the source is here a thin film which is kept on this metal plate. Okay, and here one more thing, this potential difference is applied between this silver coating of the surface of the bulb and the metal plate. Okay, here you can see the connection, right? Okay, so here you see, to conduct electricity, okay, so there must be, this gas inside the bulb must be ionized, otherwise current cannot flow through this, as there is no any wire connection here. Okay, so now alpha particle emitted from this source, they pass through the gas inside this bulb and reach the surface of the bulb. Then that's why this current continues. Okay, and so if we draw the current and pressure inside this bulb of this gas, if we draw a graph, pressure and current graph, we get a straight line up to a certain pressure. Okay, so if you increase the pressure, okay, after a certain point this current will not increase. Okay, so this is at this point the current we used to get, that is saturation current. Okay, so that is all about the experiment. Now here you see, the range of this alpha particle here is the radius of this bulb. So now you see, at critical pressure at this point, this pressure at this point is called critical pressure, when we get the saturation current. So here you see, the maximum range that alpha particle can travel is equal to its radius of this bulb. Okay, so if that is the case, then from this relation we can from this radius we can find a range here. So you see, the range, let me represent it by capital R, it is inversely proportional to the pressure. Okay, so at any standard condition, suppose the pressure is PS, okay, and this range is inversely proportional to this, and the range is equal to the radius at the critical pressure. Okay, so combine from these two relation, we can write that R by small r is equal to PC by PS. If you take constant here and here, this constant will be cancelled out, right? So we will get this relation. From this relation we can calculate this range. That's how we can determine range, right? And next part of the question is you are asked to write the definition of struggling. Then we need to write the relation between this decay constant or disintegration constant and the relation between the range and disintegration constant. This is the relation which is given by Giger-Nuttall law, and before that you are asked to write the answer definition of struggling. So let me write the definition here. Okay, here you see the alpha particles of same initial energy, the alpha particles of same initial energy have more or less the same range in given substance. More or less have the same range in a given substance. However, a small spread in the values of range though it is same, but there is a though we are getting that more or less have the same range but not exactly same, there is a spread in values of range, that means there is a difference. Okay, values of ranges about a mean value is observed. Okay, so this phenomenon is known as struggling of range. This phenomenon is known as struggling of range. So hope you have understood this. Now let's move on to question number 4b. This is 4b. Write down the equation showing the three modes of beta radioactivity and describe the role of neutrino explaining continuous energy spectrum of beta particles. So let me give you the answer directly. Here is the answer to question number B. This is the first mode, that is minus beta decay. Okay, just take the screenshot or you can note it if you want to know. And this is the second mode, that is plus beta decay, and this is electron capture. This is the third mode. Okay, and the role of neutrino in in continuous emission spectrum of continuous energy spectrum of beta particles. Here is that explanation. Okay, so just take the screenshot. Okay, so this is not ended here, so you have to write this also. Okay, so hope you have understood this. So thank you for watching. See you in the next video.